afternoon, everybody. Today we will discuss last lecture, not in the course, no, last lecture for the solar cell. Okay, today we will finish the solar cell. One question in the final exam and second exam on this lecture. Okay, one question, no more. And next week we will start with a new topic, wind turbine. We will study everything about wind turbine, design, operation. Then we will discuss after 2 or 3 weeks the hydro power plant. Okay, the hydro power plant is very important. Then we will discuss another renewable energy sources. Okay, so from today we have 6 lecture notes, 6 lectures. Okay, so 6 lecture notes. 6 weeks. Why? Because last 2 weeks is the second exam and final exam. Okay, so we have 6 weeks, no more. Today, solar cell, 2 or 3 weeks wind turbine. I think 2 or maybe 3. 2 is enough. And 2 for 2 or 3 for hydro. Okay, and 1 another renewable energy sources. Very important term in solar cell is MPPT. MPPT means max or maximum power point tracking. We tracking for max power from the solar cell. So our objective should be get max power, okay, and from the solar cell or PV cell. Now, what is mean by maximum power point tracking? It is a technique, this technique, okay, or way to know the max power value. So it's a technique used to maximize the power output in the solar panel. We can use some techniques. Most these techniques as software and interface with the hardware. Hardware used for this technique is DC to DC converter or DC to AC converter, I mean inverter or DC to DC chopper, DC chopper, step up, step down chopper. Okay, so we can mathematically we can calculate MPPT on this curve. This curve, not this curve, this curve, just this one, this curve, relation between power and V. This is max point, this max power point. We're talking for this one, okay, for looking, we looking this point. How to get this one, okay, we have another curve, current voltage curve, okay? So, no need to write anything. I will upload this lecture note.
The power, is it constant? How much?
This power?
Yeah, is it constant?
No, this is max power. Here, the power increase to reach to the max, then drop to this one. Why to this point, drop to this point? I will explain now. See, we need another curve to discuss that curve. Okay, why? See, this curve is relation between I and V. This curve gives the relation between I and V. I generated from the solar cell and V across the terminal of the solar cell. Look here. When V equal to 0, what does it mean? V equal to 0 means short circuit, right? So now, voltage axis is 0 for V. So this is V short circuit. Why? Because the voltage is 0. V short circuit here at this point. Okay? So means this current, because this curve, this axis for I, so this is I short circuit. And if I equal to 0, what does it mean by I equal to 0? Open circuit, right? I equal 0, this axis, this point is I open circuit. I open circuit is equal to 0, so here is V open circuit. Okay? Now, this curve is the relation between P and V. We say we need we want to know the max power for solar cell. We need just this one. Okay, just this curve. But sometimes we need to calculate another factors. Resistor or FF factor. I will explain what is mean by FF factor. So for power V here, this point is P max, and this point should be approximately this one. This is V at what? At power max. V at power max, okay? This so looking for
At 24, will you call it voltage drop?
yes. After P max will drop to reach to this voltage. This voltage, see here as example, 24, 20 volt, 24. So this is the open circuit, same. Should be this point, same this one. Why? Because P proportional with I. If I 0, so the P equal to 0. Okay, because P equal Pi, this 0, so this value will be 0. So this is V open circuit. This V open circuit. V open circuit, we say at this axis, I equal to 0. And at this axis, V equal to 0. Okay, short circuit. So after this point, the current will drop to 0, so the power will go to 0. Okay? Any question? Now we can calculate P max from this here or from another relation. P equal P max equal V at PPT, okay, times I at PPT, time at PPT. VPPT. We can calculate from, this is PPT. Okay, PowerPoint tracking. This is volt at PPT. Okay, any value here, if we assume 19 as example. Okay, we can move it to here, this one. So this current, I at PPT. Okay, that's it. Again, see, P max equals VPPT times IPPT. VPPT at max power. This value. Okay, so this value is VPPT. VPT. VPPT, same value here. 19 as example. So this VPPT. Draw vertical line to intersect the relation between IV or IV curve at this point. Then draw horizontal line to get IPPT, the current at PowerPoint tracking or max PowerPoint. Make sense? Okay, this one. Now, FF factor, FF factor is the relation between P max to V open circuit, I short circuit. V open circuit, I short circuit, not V short circuit, I open circuit. Why? Because both of them 0. So V open circuit, I short circuit. Okay.
And FF is usually less than 0, right? It's always less than 0. Always less than, or sometimes it's bigger. I'm sorry, less than 1 or less than 1?
Less
Depends.
than 100%.
Less than 1, less than 1.
This one,
Okay.
yeah, less than.
Sorry.
Okay, and not negative, should be
Yeah.
positive. Okay, again. We're looking for max power point track. Okay, max power point and solar cell. Okay, we have one curve to give the relation between P max with V. Okay, but we need another one, okay, to calculate another factors. This curve is P, relation between P is P, okay, P with V. The power will be increased. Why? Because the current will increase. Reach to max power, then drop to 0. 0 power means 0 current. 0 current means open circuit. Open circuit, so the voltage at this point called the open circuit. This point should be same this one. This curve is the relation between I and V. I and V with this one. Or maybe another curve, this curve, or this curve. Depend on the current generated. for same panel, maybe this case, this. Why? Because different time per day, the current generated is different, okay? But the voltage it should be same, but the current depends on the sun location and angle. So now,
So,
yeah.
you can give me the Q factor on this graph, on this, the other second graph.
FF, we can calculate FF from both,
For both.
should be both, but P max from this scale. Okay, yes.
So we're doing like open circuit test and short circuit test, that's what we're doing?
No, open circuit test and short circuit test, this is for transformer test. Here is same open circuit and short circuit, but is across the panel.
Okay.
Okay, this panel. Okay, here V plus minus and this I. Okay, short circuit, make this short circuit. To calculate I, short circuit. And open circuit,
Open circuit.
this 0 will be open circuit and plunger will be open circuit.
Thank you.
Okay? But for, we have the lab, upstairs lab, okay, energy lab, we have, we can measure by using SCADA or by using solar cell actual or power battery, okay, to measure the curves, both of them, the scale and the scale. Now, this PP, this power is PPT, maximum power. So the voltage here is VPP. VPP should be same as example 19, here 19. Draw the line to intersect the curve to calculate IPPT. Now FF is the ratio between P max to V open circuit and short circuit. Percent if you want to add percent times 100. This one. We can get PPT using any AI methods or any machine learning method. Okay, control the pulse for the egg bit transistor used in DC to DC converter. You can use any AI method or technique to get Pmax. Sure, if Pmax high is better, okay? Because and if FF high should be Pmax high, it's better than low. You can use neural network, fuzzy, ANPIS, or any method to calculate this power at maximum. Now, if we want to calculate R load, require R load, we can use this formula, okay? Because R load, any R equal V squared divided by P. Okay, so R load equal V PPT divided by PPT or P max. Okay. This R. Now, again, I will upload this lecture note today with the two assignments. Example for MPPT. We explain how to work MPPT on the curves. Example, it's not required for review, this one. Okay, example 1, we have max power P max 250 and open circuit 37 and I short circuit 8.5. Suppose solar impedance is constant at 1000 watt per meter square and the temperature 25 centigrade or Celsius. The max power point at 30 and 8.3. Again, I will have this one. From the information, we have two curves. This power and this V. It be this one. And we have another curve, I with V. This curve. Okay. Now, max power 250. This is P max. 250. 250 watt. Max power at VPPT. He said open circuit, this open circuit. V open circuit 37 volt. Okay, he said open circuit voltage, short circuit 8.5. Where is short circuit? This one, right? I short circuit equal 8.5 ampere. Now, suppose the impedance on this temperature